Well, welcome. It's Thursday night, and we're doing a Zoom, Ann Arbor solar story tonight. And before we get into that, I need to thank our sponsors, which is the State Department of Environment, Great Lakes, and Energy, EGLE, Homeland Solar, McNaught and McKay, Iron Ridge Racking, Harvest Solar, and Shree Energy. And I know many of you are GLRA members. If you're not, we would love to have you join. You can do it just by going to our website, www.glrea.org, and you'll see indications of where to click in order to kind of join online. And if for some reason you didn't want to join online, you could always contact John Freeman because his contact information is on the website. I'm looking forward to tonight's presentation by Peter Avram. He's an Ann Arbor resident, a mechanical engineer, has had quite a journey getting his solar system and also battery backup. And so with no further ado, I'm going to turn it over to Peter. And please, everybody, mute yourself until we get into the question and answer period.
Cool. Thank you, John. Yeah, thank you for the introduction. Hi, my name is Peter Avram. I was asked if I wanted to do this, and I said, yes, this would be cool. Let me share my screen, start my presentation going. So to John's point, I have kind of had a longer than most people I've talked to journey on trying to get what I wanted. Here we go. A little bit about me. So I live in Ann Arbor. Married, father, 3 kids, and all that entails with all the various gadgets and things constantly running in my house. I'm generally considered a big nerd. Michael James on this call knows me, and hopefully he can attest to that. I'm a mechanical engineer, so I do nerdy things at work too. For context, we live in about a 1,500 square foot home built in the 1960s, typical wood framing and the insulation and, quality therein. My daily driver is an EV, so that has an additional load on my energy usage. And so why I chose to go with specifically my solar system design. If you look at all the different things about setting up a home backup system with solar, I kind of said yes to all of them. So I wanted cleaner energy than fossil fuels, right? I don't ignore the fact that there's a carbon footprint for making the hardware, but it's overall over a long enough time scale cleaner than my fossil fuel usage was. Really big important thing for me is resiliency in the face of changing climates and aging infrastructure, right? DTE didn't treat my neighborhood too well over the last year, so I kind of wanted to help out with that. Community resilience is a really big thing too. Whenever we've had outages in our neighborhood, I was usually someone who had a generator, so I would let people come over and charge devices and stuff. There's also the cost savings and overall investment impact. And then for another big important thing for me was energy optionality, right? I wanted to be able to, if I needed to, use the grid, use solar as much as I could. I have battery backup, but then also have the option of a backup generator to supplement the whole system for like prolonged low solar load periods, and just another option. I also figured too, I live in Ann Arbor, we tend to like renewable energy, so it would increase my home value. The new tax incentives are pretty fantastic, that it's 30% across like everything. And I also, one key thing that I wanted with the system that I ended up getting was the ability to expand the system later. I didn't really want to be limited. We do plan to do an addition on our home, and I wanted to use up more of that roof once we get that done. Some downsides for people that don't really, aren't too fully aware of everything. It doesn't always work out for everyone, right? Like if you don't have a proper roof, or like your roof isn't big enough, or it's really convoluted, or the orientation's bad, it just sometimes might not be worth it. Also, what your surroundings, surrounding buildings, the topography, like not Michigan, but you could be up against a cliff. If you never have sun on your roof, that's kind of a bad thing. Vegetation's a big one, especially in Tree Town, right? Like we have some slight vegetation issues, but it really depends on the time of the year. Weather impacts performance too. I used to live in California for a while and it was sun all the time. Here, we get clouds and weather, which I personally really enjoy, but it does impact solar. So sometimes I'm like that angry guy yelling at the clouds. Cost is also a big prohibitive factor for some people, and cost is directly tied to complexity of the system and what you want to get. And for some people too, it's too complex. Like we've had neighbors come and look at, I'll show pictures of it later, but the installation on the side of my house and the kind of Frankenstein looking interconnection of electrical stuff because of my system. And they're like, that's too much for me. I just want a meter and that's it. Right. So there's some feedback I've gotten. And some of you may be really knowledgeable, some not so much. In my investigation of it all, right? A solar system can be as simple as you have some panels tied to an inverter that feed into your house, and you can net meter out to the grid if you are in a place that allows that. Or it can be as complex as a fully off-grid, fully supported system where you have all the bells and whistles and nothing knocks you down, right? So this is actually the wiring diagram of what I wanted to get installed from the inverter manufacturer I went with. And these are also the same brand of batteries that I got, I'll get to in a bit. But there's a range in between, right? Like some people just go for, I want to offset some of my usage and sell back what I don't use and call it a day. Again, when I looked at the checklist of things and optionality, I said yes to as much of it as I could. So my system, we have a 12 kilowatt solar array, which is about 33 panels. I have a 19.2 kilowatt hour battery pack. It's a lithium iron phosphate chemistry, home grid brand battery pack. I use a Solarc 15K hybrid solar charger or solar inverter. And so it's this kind of like central hub that handles everything. And I can get into detail that in a little bit too. It was really important for me to have a backup generator hookup, right? Like I wanted to be able to, if we have another ice storm like we did last February, where everything's down for days on end and we have cloudy coverage, I can supplement my system, but still have my battery. So the thinking was the battery is handling all the loads for the whole house, and my generator can top it off during low solar events. Other important thing for me too was a bypass option, so I could completely isolate the solar system in case there was, hardware went bad or something like that. That's getting into the nuanced kind of stuff about my system. I'll go into more detail in a bit. And after credits, so far we spent about $41,000 on everything. So I participated in the Ann Arbor Solarize group buy event that I think goes out to all of Washtenaw County, but it's comes from the city of Ann Arbor, and it's this group buy thing. I was a host of a session last summer where I talk about my process, what I went through, and get people excited about it. And then we partner with a solar installer, and depending on the number of people that sign up, you can get anywhere from 0 to 5 to 10 to 15% off your system. In my case, it was 15% off everything but the battery bank, but the batteries that we got. And we did that with Strawberry Solar out of Detroit. Cannot say enough good things about them. They were fantastic. I had a really good experience with them. And then on top of the 15% off, you get the 30% tax credits if your tax situation applies to it, right? If you pay zero taxes, then it's not really going to help you. Outside of just getting solar to offset our energy consumption, we also have an updated and efficient HVAC system, but it relies on natural gas for the heat. Eventually, if we do get around to doing the home additions we want to get a heat pump or investigate geothermal so we don't have to leverage natural gas. We have newer windows, draft mitigation, went through with the thermal imaging camera and made sure we didn't have any leaks and stuff. Updated attic insulation, LED bulbs throughout, and all appliances are electric, even a water heater, and that hopefully one day will get upgraded to a heat pump water heater as well. The goal is leverage as much of the solar production and battery backup as I can, but it's kind of on a longer time scale. And so this is a drone picture of kind of looking south at our house. So we have slight vegetation issues in the later part of the summer where the tops of these really tall trees start casting a shadow on these lower panels. I'm hoping that in the winter, when all the foliage is gone, it's going to be less of an impact. But it's something to consider too, right? If you are surrounded by trees, it can definitely impact performance. And one thing too, just to get started to see if your house is even worth, messing around with it. Sunroof.withgoogle.com. It's a free website. You can go punch in your address, and they have most addresses in the US from what I've played around with. And they give you an idea of, it's like a starting point just to see. But when you talk to solar installers, they'll give you detailed analysis and help you understand it better. So continue on an overview of my system. Here's a top-down view. Ignore these little panels in the bottom. That was like a science project thing. But all of our panels, we have 33 on, we have 2 south-facing sides and 1 north-facing side. Try to shoehorn as many on there as we could. Didn't do this facing side just because I kind of wanted to keep it within a certain budget. This is a picture from the manufacturer of what my inverter looks like, and it's pretty big, but it handles everything. The standout difference with this is my system will handle the whole 200 amp service coming from DTE, and I can show kind of what that looks like in a bit. And this is what my battery backup in my garage looks like. And another important thing for me too is pretty much every system on the market lets you monitor remotely what your power generation is, and depending how it's set up, what your energy usage is. I wanted to keep it within this, as off-grid as possible theme. And I actually have a Raspberry Pi, which is a small computer that runs this software called Solar Assistant. So I have my own on-site constant data logging, in addition to the remote data logging and monitoring that my solar installer used. So the takeaway is that if I were to just snip the lines from DTE and Comcast, everything else, it's all fully self-contained on my property. So just a little add-on that you don't have to totally rely on whatever vendor you're using. If you go with Enphase, Tesla, stuff like that, there are options out there that let you kind of piecemeal your own system together to get more functionality out of it. And you can nerd out on it as much as you want, pretty much. Continuing on, my actual install, we had to install pretty much everything outside, because where I wanted to install everything inside of the house ended up becoming my wife's office during COVID. So I was forced to kind of go outside. And this is on the corner of our house, and we have 2 meters. One is an interruptible one for our water heater, and then we have the main 200 amp service line that comes in from DTE. So what's different from this system from other systems you can get is that the DTE line comes in. Hopefully you guys can see my cursor. So DTE comes in, and then it immediately goes to a disconnect. So this is my first breaker. So normally your 200 amp line comes in, and then that goes into your house, and you have a big breaker to throw it off. We bypass that. We have that outside, and then it goes to this big 3-way switch where I can stay fully on grid, or I can and isolate my solar system in case one of these components goes bad, or with this lever down, I'm going off the solar system. So it goes 200 amp in through this transfer switch into the inverter right here. I have a kind of chintzy cover just so I don't have UV damage on the LCD panel until I get a proper cover on it. But the important thing that makes this so robust and awesome is the whole service panel or the whole DTE service of 200 amps is managed by the hybrid inverter system. So I'm not like I'm not doing a line side tap into my breaker panel. So it manages everything. The beauty, like what you get with this is you get like, it's like an UPS system for your whole house, like an uninterruptible power supply. For context, I have neighbors that have like Generac power cell systems, and when we had outages in the past, they would have to wait from like 1 to 3 seconds for it to switch over, and they only had like 6 or 12 circuits, I can't remember exactly, that were pulled out from their breaker panel to that was supported by their battery and solar. This handles it all. So over the summer, I tried stress testing it. I'd have my AC going, we'd have our electric range going, we'd have the electric oven going, my home server, kids' iPads, TV, and even just to see if I can overload it, I threw my EV on the charger to see if I could like, and it was getting up there where it was like pulling 20 kilowatts of power. Like it was kind of freaking out. So I dialed it back, but it was completely off grid, still in Ann Arbor, supporting everything. So that was important to me. I wanted to be able to run my AC. I want my comfort. I didn't want my kids to gripe that, you know, for whatever reason, something didn't work. So yeah, so I kind of wanted it all. Other things to note too is I have generator hookup connectors to, and this is the model generator that I have in the shed. So this system also allows for the connection of almost any generator on the market. Some other systems you need to have, like Generac, for example, latest understanding I have is you can get a pad mounted DC whole home generator that is directly coupled to their system. Or like Enphase, you can use certain types of pad mount generators that are approved, or other inverter generators that provide clean like energy, like sine wave signal. This guy will take anything you throw at it so long as it connects to it properly. So that was another important thing for me too, is I want the battery to manage loads, but I want to use the grid, solar, or generator to supply that battery, because the battery handles load management so much better than any internal combustion generator you can get. Because either you're going to run that generator at a higher setting so it can handle the fluctuations of your loads, or you're going to run it on a kind of eco setting, and then it'll ramp up RPMs, and there's a latency or a lag between trying to pick up, right? So I wanted to make sure that my battery handled stuff, it could handle everything, and I had multiple ways to top it off. So this is the kind of monstrosity of stuff on the outside of my house. And then I've since then installed like a privacy fence around it. One thing to note is I chose to go with liquid tight connectors. Some of these installs you'll see use these things called troughs. And just to note, in my experience, the electrician we had was phenomenal, but he brought up that Ann Arbor might not allow like mixed use or mixed voltage cables in the same trough. Because effectively what you have is you have high voltage AC, and these are 48-volt batteries, so they're low voltage DC intermixed. And so we kind of wanted to avoid it and keep everything separate for inspection purposes. If I were to do it again, I might push for a cleaner install and talk to the city beforehand to see what their complaints might be, just kind of noting it. And this might be kind of, scattershot of comments. The other thing with my space constraints, because I couldn't install this in the basement like I wanted, I ended up putting our battery system in our garage. So to go back here, the meter and the inverter and everything's over on this corner of the house. We had to run conduit inside of the basement all the way into the garage, and the battery's about here where my cursor is. So that was additional cost, but it also comes at a positive that it's my understanding that the next generation of electrical code is gonna, there's some additional guidance as to where you should park batteries, right? Because they are a fire hazard, right? There's a chemical reaction going in, and so I I wasn't super concerned about having lithium iron phosphate batteries in my basement versus like NMC or other chemistries. But I do feel better knowing that it's separate in a garage, not close to a living space, as if it would have been in my basement underneath, a bedroom or the living room or something. Just want to highlight that. So yeah, we kind of have this Frankenstein project that we went with. So to go into kind of my design journey with it, when I initially said yes, I'm going to budget for solar. I want to get it going. This was back, I want to say in like early 21 maybe. Um, and again, right, I went through the checklist. I said, yes, I want solar. I want battery backup. I want to be able to hook up a generator to it. I want it to handle my AC. I want it to handle the whole house load. And I started shopping around. On the one hand, I was talking to different solar installers. And then on the other hand, I was doing my own research as to what is actually on the market, what's available. Um, Pretty much was told what I wanted didn't really exist, or it'd be really cost prohibitive or a super huge pain to do. And so I talked to about 2 dozen different companies all around like the southern half of Michigan that were willing to service Ann Arbor. Out of all those discussions back and forth, only 3 entertained doing what I wanted to do. And the thing that I got from it was a lot of them had interest, but they had no experience in it. They were used to kind of just doing what I called like boilerplate systems. Like, yeah, we'll get you an end phase, system and put it in your house. This is what you want. Or a Generac system or Tesla, or Solar Edge, or any one of the kind of bigger names. And so I had a lot of companies telling me what I should want versus, yes, we'll work with you to get you what you want. And so it took a while, and I had some dry spells where I, kind of stopped talking to people for a little while. And then it got down to like about 3 companies that were interested in actually moving forward. And then out of the 3, I ended up going with Strawberry Solar. They honestly seemed the most willing to nerd out on the science project with me. Like, because I flat out told people, I was like, hey, this is going to be a science project. I'm not on a set schedule. I'm fine, like, going through a bunch of design iterations. We educate each other on it because they seemed really interested. They said, yeah, we've had a lot of customers come ask for these kinds of systems, but we've never done it. So yeah, happy to try to, co-educate each other, I guess. Um, Guys were awesome. And we spent a few months kind of going back and forth on the reality of what I was asking. And then they did all the legwork and dealing with DTE, which was awesome. And we came up with a tentative plan and then kind of went through it. Yeah, highly recommend them. And then, oh, here I talk about the Solarize part. The I guess the positive and also frustrating thing with my approach or the design that I went with was I used a bunch of different disparate systems, then combined them together, right? I kind of acted as a system integrator. Like if you want to go with an end phase system, you can get their micro inverters on panels going down to their inverter, and then their batteries. Everything communicates really nicely together. It's a one-stop shop, right? But I also have a thing against being in walled gardens. Like I don't use only Apple products or only Android. I like the differences of stuff. So that was one thing that was led to kind of a longer time scale in getting everything up and running, is because we would have Tygo DC optimizers on the solar panels, and we'd have the Solarc inverter, and then we'd have a home grid battery, and we had to make sure everything communicated well together. And it was supposed to. There's a few hiccups on the way, but it was mostly just a learning curve. If we would do it again, totally bang it out so much faster. But the other beauty of having it that way is, God forbid Strawberry Solar goes out of business. I can fully handle and manage my own system now. Like that was something I wanted to do. I have friends with Generac systems, for example. I don't want to keep harping on them, but they're just like two houses down, and they're beholden to the installer working with Generac to get it fixed. Like they hit roadblock after roadblock of trying to like fix it themselves, right? They're reliant on someone else to come out and do the things. I didn't want that. I wanted to be able to, if it's a problem, I can fix it myself as much as possible, or just use the warranty if I'm being lazy and get them to come fix it. Yeah, so go down to installation issues. It was not a typical install, but I was abundantly vocal that I knew it would be a design process, it'd be a science project. It was totally cool. Um, I needed to really be flexible on like last minute quick decisions with stuff. Mostly, my wife didn't want the inverter in her home office because there's a fan that kicks on and all these new conduit cables. And so I was like, okay, let's design this for outside instead of inside. Um, I also knew that I'd have vegetation issues from really tall, beautiful trees we have in our backyard. But, you know, that kind of came into my calculus for, okay, like I know that I'll have these low points during these, you know, parts of the day, during this parts of the year. Um, and I mean, one lame thing was I really didn't get the full system up and running until late July, early August. And that was just to get the iron like kinks worked out to get it running, and that was before I could net meter back to DTE. So I didn't really get to, you know, nerd out over the summer, but we had plenty of days where we were effectively off grid all day. So we would produce so much during the day that we would have to curtail production because my car was full, the batteries were full, and then the battery would run all night and then it would start up again in the morning. And so yeah, that was just like awesome when we got everything up and running. I was like, oh, DTE for like a week. This is great. Um, let's see. So what's next? I want to double the size of my battery that I have because there are these modular, like interconnected, like each one of these modules is a like almost 5 kilowatt hour battery pack. And they have these blind mate connectors. You just kind of slap them down, bolt them together, and then they all work in unison once you put them all together. And each one of these stacks you can put up to 8. So I have 4 right now, so I'm going to go up to 8. Um, let's see. When we do eventually do a home edition, we want to kind of expand out our garage and get a bedroom installed or added on. So that would give us more roof space. Definitely want to coat them in solar panels. One thing I would love to do is change out my home EV charger for one that adjusts its output to charge your vehicle based off of what you're net metering out. And there's a couple options on the market now that will do it like per kilowatt. So like my charger right now will output 11 kilowatts of power to my car, but there are ones that will curtail and adjust its output to the EV based off of what it's reading that you're net metering out to DTE. So instead of selling it for pennies on the dollar, I could just dump it in my car. And to expand on that, I would love it if I had bi-directional charging. Like I have a Ford Mach-E, and I know the Ford F-150 Lightning has a bi-directional charger you can get for it. There's always rumors that eventually Ford might do it for the Mach-E, or if I could convince my wife on her next car if she wants an EV or a PHEV that has that option. I think that'd be cool. Just you can dump production into your vehicle and then pull it out when needed to. But the issue with that from a lot of manufacturers is it counts against battery cycle counts. So I think that's why a lot of OEMs are apprehensive in doing it. And I think that's pretty much it. I blather on for a while. I'm at the like halfway point. So I don't know if you want to jump into questions.
Yeah, that was great, Peter. Yeah, and you were just halfway, so you're right on schedule. If you want to stop the screen sharing, we'll see who has questions. If you want to, you can use the reactions tab and raise your hand. And let's see, I'll check the chat area too, but if you have a question, just raise your hand virtually.
Dale has a question on the chat. Any issues with DTE and how the system would be isolated from the grid? Yes, very much so. They were, I don't know how to put this. As an engineer, like when you're negotiating with other engineers and you're trying to discuss interfaces and stuff, there's usually a back and forth. DTE, I could almost say, was like being obstructionist. Like they would highlight issues on our drawings and just say, yeah, fix it. I mean, effectively. And then, so it was, thank God Strawberry Solar was patient and awesome because they worked with them and figured out what to do. So we did have to add a 200 amp disconnect for them to be able to throw whenever they wanted. And that was a big box on my image, like my image that I had my like whole meter setup. It was a huge 200 amp breaker over to the left. And then other question is the box. Yep, that was it. Is the box the far left solar disconnect? And then yes, rapid shutdown is managed by the Tigo system. So it's a bunch of DC optimizers on each panel. And then there's these like central gateways that make it a mesh network. And so the optimizers we have optimize solar production for each string, and then they also initiate rapid shutdown. So that's how we did that. Let's see, hot water heater question. We have a separate meter and get a better price. You have a separate meter, hot water meter 2. Why? We moved in, we had both meters. And so we just kind of kept it. But what I didn't show is that I have a 3-way switch, 100 amp 3-way switch in my basement to be able to bypass that meter, right? So the thinking is DTE is down. I want to be able to dump, solar production into my water heater, which acts like a thermal battery. I just switch the input from, either it comes from that second meter down or it comes out of a 30 amp breaker on my panel to feed into the water heater. But that's super manual. That was an add-on I did. DTE, I did a full DIY, much simpler, and DTE was very good. Dude, I'm glad you had so much, like, DTE was very frustrating to me. So is it Jens or Jens? I don't know. I'm glad they were cool with you. I had a really difficult time with them. So
yeah, Peter, did you have any issues with the city inspector?
No, they were awesome. Like they approved our permit super fast. The inspector came out and he, I guess, really likes the electrician that we had, and he complimented on his work, and then we did the thing, and that was about it. And he put the sticker on and said, "All right, see you guys later." That was about it. And drove off. So no, Ann Arbor was great. And I think it's also a big push too. They really want people to do this kind of stuff, so they remove as many hurdles as possible.
Go ahead, Craig.
Yeah, Peter, one thing you mentioned that I was not aware of being available yet is the idea of having an EV charger that would be able to tell how much excess generation was going on, then send just that to the EV. I have an adjustable charger and I do it all manually. I have time to watch what's going on and got to adjust it up and down an amp or two, and but that obviously doesn't work when I don't have the time and patience.
Yeah, so the two that I'm aware of that I was looking, there's SolarEdge has one that ties into their system, and I think you need to have a bunch of their components for it to work. But the one I was interested in getting is I think it's Emporia. They're known for like having like energy usage kind of monitoring systems. So you would put these CTs, or what are they called? They're like current
transformer.
Yeah, there you go. Sorry, I'm like drawing a blank here. So you can get them where it's as simple as going to your main legs of 240 coming into your breaker, or on each circuit. But they also have a charger that works with that and it'll monitor how much you're sending out. And then I think like it'll start at like, I can't remember how many kilowatts, and then it'll up it. It like will stair step like 1 kilowatt each way based off of what you're net metering out. I just thought that was a pretty clever approach, but I have like a good charger already, so I don't want to like waste the money kind of thing. Yeah. So that's what I would look at, but hopefully more come out. So
Thank you.
sorry, my monitor wanted to shut off. I don't know if I should do a chat or go to John.
Go ahead, John.
Yeah, thanks, John. I wanted to ask if you had any problem with the size of your array compared to your household usage for the year. It sounds like your array is pretty big.
Yeah, DTE capped us at like 14 and some change kilowatts. We would have been pretty close to that, I think, if I used the other remaining portion of our roof. But that calculus from DTE did not factor in my EV usage. So I think you can get it changed as your usage changes. But yeah, so we would have been up against a wall, but if they would have pressured me, I would have said, hey, I just got this EV and here's my expected usage. And for context for people, like DTE will cap you on how much generation or net metering you can do. So yeah. Yay. Let's see. If I'll go to the chat real quick if people are cool. So Dale says found $250 per month charge. Yeah, I'm kind of with you on that. I go back and forth if I should keep it or not. And I wondered if Tesla had a variable charger that worked with their system. I mean, it totally makes sense. Oh, I guess Enphase just released one too. And then, oh yeah, the cloud connectivity. Yeah, Dale was talking about downside of Emporia is that you have to be connected to the internet. That was one thing too that I'm just not a fan of. And to go back on like Generac systems, for example, in certain black start conditions or situations with their system, like let's say you get an error or something happens. Some of my neighbors have had it where you need power to start your system to use the battery. It's this kind of catch-22. And one of them managed to black start it to work, but they couldn't use the power from their battery because they couldn't clear an error code because they didn't have internet access, right? So they managed to like get their system to start in a black start event, but they couldn't clear the code because their internet was down. But they had a full battery that's tied to their house, right? So that was one thing for me is like, nope, I work for an internet kind of company and I sometimes need to, cut that cord. So yeah, just that's another thing to keep in mind for some people too. Like how resilient you want to be, internet does factor in.
Hey, Peter, with the time of use rates that we all are dealing with now,
Oh yeah.
do you have any kind of strategy for, since you have some batteries,
Yes.
how to manage that?
I totally spaced on mentioning that. I can actually share my active usage right now. So this is, can you guys see my screen?
Yep.
So this is my Raspberry Pi running my data monitoring for my solar system. The other benefit too is the solar or the monitoring stuff for my solar arc inverter updates every like 5 minutes. This is like every couple, like 2-3 seconds. So right now we are not touching DTE. So red line indicates grid power, and we have been off DTE since about 10 or so this morning, and we're currently running off of the batteries. But I also have it set up too where if it's super cloudy, like there's really nice time of use setup in my inverter where I'll make sure the battery stays at a certain charge. So we run through that during the time of use. It's like 3 to 7 p.m. So we never use DTE, even if it's super cloudy, because I can charge my battery up earlier in the day at a cheaper rate offset using it at a more expensive rate later. So right now we're totally running off of the battery. And you can see these spikes. These are from using I think my wife was reheating some food for the kids upstairs with our electric range, and this is probably the microwave using it. So yeah, it's really nice to be able to have that flexibility too, because when DT announced it, it's like, that's cool. I'll just, adjust my time of use settings and not have to worry about it. Any other question? Oh, I see some there. I got to scroll down. You are using lithium batteries. Are they more susceptible to fire problems? It depends on the chemistry. So I went with lithium iron phosphate batteries because they are supposed to be more stable. And they don't like temperature extremes as much though, but mine are in my garage, so it's not going to be really a concern, but you can get self-heating pads for a lot of batteries out there nowadays. But the other thing I wanted with lithium iron phosphate is the cycle counts, right? If you go like research battery chemistry and number of cycles, like a lead acid battery, you're going to get like, if you do like a 0 state of charge to 100, like something in the like 3-digit number of cycles before they're effectively useless by whatever metric on that chart. Whereas the lithium iron phosphates on the other end. So depending on the construction and the chemistry and the usage, you could get like 3, 5, 7,000 cycles, right? And so that's the other thing too, is barring a power outage, I use my battery from like 50 to 100%. So I'll top it off and I'll let it go down to 50. So I keep some in the bank in case there's a power outage overnight. And when I double it, it's going to be even better. But that also helps extend the cycle counts on the batteries. Same thing applies to like EVs, right? Like that's what the state of health and the battery pack life is a function of like how many times you charge it and discharge it, and the ranges. So I was going to say something with it. Yeah, so I was really happy with that so far. The other thing too, on the topic of batteries, and I'll get back to answering more, is not all battery packs are created equal, not only in just their chemistry, but their charge rate and their discharge rate. Right, that was another thing too, that why I went with the battery pack I got versus some other brands is I can kick out, I want to say just on the battery alone, like 14.4 kilowatts of continuous power with a pretty high peak above that. And for our home usage, I mean, that would cover all the lights, all our computer stuff, the air conditioner, and we can cook dinner in our electric range oven, all from the battery, and it doesn't miss a beat. So that's another thing to look at too, because we have neighbors that have installed backup battery systems and they're severely limited in how much you can draw out of them. Is there a good source that would compare batteries in terms of safety? I don't know. Like I just looked up different battery chemistries. There's was it NMC? I think it's nickel manganese cobalt is a big one. That's what a lot of other batteries are. Lithium iron phosphate is definitely on the safer side with higher cycle counts, but I think they tend to cost a little bit more. Next question is, what is the incline of our roof? I want to say it was 18 degrees, so it's kind of on the shallower side. So you have to factor that in too. And there's other stuff too, like if you want to get really fancy and depending on what kind of installation you do, you can get bifacial panels where you generate on the bottom side too. So let's say you don't have roof space, but you have a lot of yard space, you can do a ground mount installation and you're offsetting it from the ground and you're betting on, that secondary like light bouncing off of the surroundings and hitting the underside of the panel. That's always an option. I think it really depends on your cost benefit analysis of it. That we didn't even consider it just because we were just going to slap them super low to our roof. There's no light that bounces underneath. Let's see. I think that's it for the chat questions. Anyone else have questions?
Well, Peter, what about, do you do anything related to snow?
I don't know yet because we
Okay.
haven't really like we had that dusting what just a couple nights ago. Um, but yeah, so that's I mean, we haven't dealt with snow yet because we just kind of got it up and running this summer. But that again too is why I wanted to be able to hook up a generator to our house. Um, I have a generator, it's plumbed in my shed, so all I have to do is run the cord and then hit start, and I have exhaust that's plumbed out and it's, vented and everything. Um, but I mean, the reality of living in a state that has weather is you'll get cloud cover and your solar production plummets, but you still want to, keep the lights on, right? So that's where the generator was really nice. Um, but again, right, like I can hook up a small 2 kilowatt generator all the way up to a huge generator, and it just takes it all with the system that I had put together.
We have a question about
Oh
the
yeah,
cost breakdowns,
excuse me.
approximately the
Oh
breakdowns
yeah.
between the panels and the batteries and the labor.
So the battery I want to say was in the low 20s because it's a decent sized battery. So let's call that like 21,000. Um, the inverter, because it's a pretty robust like hybrid inverter, right? It handles the full 200 amps. So it's huge physically, and even just looking at the lugs, like we have 4-aught cable coming to it, which like is the size of my thumb inside of the sheathing. Like it's just super robust. So that was an additional cost over if you went with like an Enphase inverter or Solar Edge or something, right? So with my panels and the nicer DC optimizers and my much more expensive inverter, I think I still came out to about like $3.80 a kilowatt, or sorry, a watt, for that, excluding the battery. And then other additional costs that I had that most people won't is I had to do 4-aught cable through 2-inch conduit for 65 feet through my basement into the garage. And copper's not cheap at all, right? Especially nice, flexible, you know, it was effectively welding wire because we needed the flexibility to get it to the garage. That was, a real cost. So there'd be some variation in there, but even with what I got quotes from some solar installers well over $4 a watt, and it was what I considered like substandard, equipment for what it was, right? So definitely shop around. Um, and I mean that's one metric to use. Don't get super hung up on it, right? Because I added batteries, I went for a fancier inverter, and I added, like generator interconnections and transfer switches and all sorts of stuff. Um, let's see. Hopefully that answers that question. Michael James, did you consider a rack mount with a larger incline? Nice. Yeah. Well, no, because the issue that I would have faced is like if you wanna target a specific sun angle, right? If you have these like mismatched kind of angles of your panels, then you have to account for the sun hitting those panels, and then you're increasing your footprint on your roof, and we don't have that big of a roof, so I try to optimize for getting as many panels on my roof as possible. Hopefully that answers that. Snow, wait for sun. Yeah, my neighbors that have panels, they say the snow usually slides off pretty quickly. Yeah, I was seriously looking at Enphase, but that was the kicker for me. Was the most I could find at the time was they had a black start option where you could like kind of jankily and hook up some wires to it to get a generator hooked up to it, so you could get your batteries over like 20%, so they could start charging again. Um, no, I wanted to be able to like, yeah, the inverter's broken. I could just throw the switch over and hook up a generator and just run it like I did before I had solar. Um, yeah, let's see. Any other questions?
Oh, Dave's got a question. Go
Dave.
ahead, Dave.
Just in time. So the interface between your system and your generator, can you describe what that is?
Yes. So before we had solar, I had a generator interlock kit. And so there's like, just like with solar, there's a range of getting power from a generator into your house. It's everything from as simple as I have a generator on my back porch and I'm running extension cords through a cracked window or a door and I'm hooking up, my laptop and my fridge, all the way over to you have a pad mount permanently installed generator that supplies your whole home, like a massive 28 kilowatt generator, right? I didn't want to go that far because I didn't want to be reliant on needing a huge propane tank or natural gas. So I went with a generator interlock kit, which you have either a 30 amp or a 40 amp twist lock connector. So it's about like 2-inch in diameter, it has 4 contacts, and it supplies 240 volts split phase power to your house. And what it does is you hook up this connector to your generator that energizes, like it backfeeds a 2-pole breaker on your breaker panel. And there's a physical plate. So I don't know if you're familiar with how your breaker panel is, right? You have a main breaker at the top, and then you have rows of these, like 2 rows of like each leg of your service. So your generator feeds into either a 30 amp or a 50 amp breaker at the top, and there's a metal plate. So when the power goes out, you turn your main breaker off, so you're isolating yourself from DTE or consumers from the grid, and then you move this plate up, and then you throw the other breaker that feeds your generator, or that's coming from your generator. So then that generator breaker energizes the whole breaker panel. And so what you're kind of doing is you have this, like metal plate, kind of very manual way to energize your whole panel from a generator outside. Other option to that is you can get an automatic transfer switch, but they usually come with like a breakout of panel or a breakout of circuits. Like you identify which circuits you want. It's usually like 6 or 12, and then it'll go into a separate box. So with those, it's nice because it's like, oh, it's less fussing, and it'll automatically kind of switch over when the power's back. But again, right, I wanted to be able to run everything, so I want the option to go in and pick and choose what I want. So I have the same kind of connector that feeds directly into my inverter. So that 4-prong connector that's outside of my house, when I hook up my generator to it, instead of it going directly to my panel, it feeds directly into my inverter. And then the inverter just consumes it like it's anything else. And you'll see a little icon. It switches from a grid, kind of like electrical tower, to icon of a generator, saying, hey, I'm sensing that I'm getting generator input. I'm going to use this to top off the batteries and supply the home. And so it works super, super well. Like, I'm very happy with it.
Hey, super. Hey, thank you, Peter. This has been a great presentation because you've covered a lot of different issues and different equipment types, and how you've kind of arranged things. I think this is, very helpful to a lot of people. Yeah, thanks for spending the time with us. And John Freeman, I wonder if you have any information about what's going on in the legislature before we adjourn.
Well, they're taking attendance now. The House is supposed to be back at 7:30, but they're on legislative time, which means more like probably 8 o'clock before they start getting going. But the theory and the plan is that they're going to try and finish all of their activities tonight. So keep all your fingers crossed that they will take up the solar energy bills tonight and enact them. So
You want to make a prediction? Do you think they'll pass them, or?
yes, I do think so, because I think, I don't know if you saw that there was a major article in the Washington Post about how if this legislation is enacted, it's a big win for Governor Whitmer. So I think she wants to see it happen. I think the Speaker of the House, Joe Tate, wants to see it happen. And I think Winnie Brinks, who's the Senate Majority Leader, I think she wants to see it happen. So, and I think, frankly, there is a working deal that the utilities want to have the siting be assumed more by the state. And in return for environmental groups and energy groups supporting those bills, that DTE and consumers will be neutral on increasing the renewable portfolio standard from 15% to 50%, and then increasing the distributed generation cap, which currently is at 1%, to increase it to 10%. So I think there is the makings of a bargain, a grand deal. But like anything else, it's not, you can't always, the legislature is a funny animal. There are no guarantees. So you just have to keep working. And that's why I sent out an email earlier this morning, encourage everybody who hadn't sent their emails out to their state legislators to make sure you go ahead and do that, because hearing from their constituents has an impact. So, and just so Peter knows, Senator Shu Shank she is one of the champions. She's got Senate Bill 502, which will give the Public Service Commission more authority to regulate and to regulate the utilities. So Sue Shank is doing a great job. So
Awesome, thanks.
Well, thank you, John, and thanks again, Peter, for a great presentation, and thanks to everybody who's attended. And hope you can join us next week on Thursday. We're going to have Missy Stoltz is going to talk about the Sustainable Energy Utility Report, kind of an innovative approach that Ann Arbor is looking at in order to be able to kind of do more renewable energy in the city of Ann Arbor. So thanks again for coming, everybody. And let's see.